We know that power is a rate. In other words, it is energy over time. Power is energy over time. And we can go into that really deeply and take a look at all of the units and everything that make that happen. But in general, it's energy over time, where energy is typically an amount or a quantity, and energy is measured in joules. It is an amount or a quantity. So power is energy over time, or another way we can put that, of course, is work over time, because work is another way of saying energy, but it is a quantity. And it sort of implies that, some work was done. So power is the rate of energy used, made, etc. Rate means I have divided by time in seconds. And work is energy. So what I want to look at is the different ways we can express power in useful ways for a hydraulic system. So how to express power, how to express power in useful ways, for fluid power systems, or I'll say hydraulics. Because really we're talking about hydraulic systems, like kind of big hydraulic systems here, because I am going to express these formulas in what we're conventionally using for a hydraulic system, which is kilowatts. And the big power systems that are in kilowatts are hydraulic, not pneumatic. So power in kilowatts, one of the ways we are going to use power is a rotational power. And a rotational power, the force that is applied in a rotational system is called torque. Torque is in Newton meters, and that way earlier we said power is equal to force times distance, but then we remembered that force times distance over time, and we remembered that distance over time is velocity. And we said that's a linear system. But if we look in a rotational system, then distance over time is really n in RPMs, or omega in radians per second, but it's angles. It's angles per second, right? So omega here is our common expression for rotational velocity, radians per second, or whichever angle of measurement we want to measure in per second. If we keep rotational velocity, I'll just put omega is rotational velocity. Of course, that does have a direction. It's either clockwise or counterclockwise, so I have a vector symbol on top of that. If I have it in radians per second, then in order to get the units to work out to kilowatts, I would be divided by 1,000. So this is a definition of power in a rotational system in the context of a hydraulic system. If I don't want to use radians per second and I want to use N, we're often use N in sort of our motor calculations, and that's revolutions per minute. That's not an SI notation, but it is common, revolutions per minute. In that case, if we are multiplying by Newton meters, just like above, then we could calculate that our unit conversions would bring us to 9550 in order to get to kilowatts of power. This again, revolutions per minute, this is rotational. And another way we can express that is, so the horsepower this is a completely different way to express it. This is not a rotational power, but often we can express our power of a pneumatic system in sorry, this is not horsepower at all. This is hydraulic power. This is hydraulic power, and often we say hydraulic power of a system in kilowatts, and we can also measure that. If we were to do a unit conversion, we can say hydraulic power in kilowatts, and just only for a hydraulic system. Only for a hydraulic system, I'm going to talk about flow. And we have to remember, and we have to know that flow rate is Q. The fact that we're saying a rate means that it's going to be divided by time in seconds. And what gets divided by time when we're talking about flow? It would be volume. So meters cubed per second. And this is called volumetric flow rate. Is and always was Q in meters cubed per second. So I can also express power in terms of the volumetric flow rate for a hydraulic system. So that's pretty cool. If I express it in terms of flow rate for a system, I can do that and I'm not putting the derivation here, but if I multiply the power in pascals by that flow rate, which is meter cubed per second. And we'll do lots of example problems in which case we break down Pascal into its base units and we can get to kilowatts from here. We do need that conversion of 1,000 in the bottom in order to get to kilowatts, but this will all work out. So these first two are basically power is equal to torque times angular velocity. This is rotational. It is akin to translational. We say power is force times distance. So in a rotational system, it's torque omega. Sorry, force times velocity. Force times distance over time. Force times distance over time. Force times velocity. So, and this one, these are power, rotational system. And this one is often called power hydraulic. Hydraulic power. And that's why it had an H before it, which is misleading because H stands for horsepower usually. As an aside, let's take a look at horsepower just so that we remember, because horsepower is still kicking around even in countries that use SI. It's still kicking around in industry. About horsepower, actually horsepower, not hydraulic power. So this is an H for hydraulic over here, and this is actual horsepower. Horsepower, 1 horsepower of power is actually equal to 550 feet times pounds of force in each second. So if I were to look at the hydraulic power in horsepower, translational horsepower, and rotational, then I would have force in pounds of force times velocity in feet per second over 550. And rotational, I would have to have this conversion in the bottom. I would have tau times, I would have my torque times my revolutions per minute. But if I were converting to horsepower, it would have to be 63,000 to get to that rotational power in horsepower.